Welcome to Daylight for SketchUp. In this tutorial we're going to show you how to perform a neighbour analysis. Click on the link in the top right hand corner to watch setting up the groups first before continuing with this tutorial. Okay, so we're going to have a look at number 32 and number 34. We're going to start by hiding the layers and just turning on the layers for the window faces and the room faces. Then we're going to select register from the toolbar, and we're going to look at the building names. So by default you've got the standard B1, B2, B3, and we're just going to replace those with number 32 and number 34. And just click Save Names to apply the settings. Okay, so the first thing we're going to do is create the layers for the windows. It's going to do this by building. So just click on Create Layers for Windows. And you can see we've got, for each of our buildings in our building list, we have a window faces layer as well. So we can go back to our model, and we're just going to change the layers for these faces. So these are going to go into number 32 windows, and these are going to be number 34. Okay, so the next step is to do the same but with the rooms. So we want to tell it which of our rooms are bedrooms, living rooms, kitchens. So we go back to registration, change to rooms this time, and we're going to edit the room types. Now in our example we've only got bedrooms, living rooms, kitchens, so we're not using these last two. So I'm just going to tick the boxes to select them, and then I'm going to create layers for the selected. You can see here we've now got, for each of our buildings, we have a room type layer as well. And in the same way that we did for windows, we're going to select these and put them into the correct layers, the relevant layers. So I'm going to create these as 3 bedrooms for number 32. And then 3 bedrooms for number 34. Kitchen for number 32. And living room for number 32. And the same for 34. Okay, at this stage I'm ready to start registering. So let's open the registration dialog again. First thing to note is the floor height area. This is what tells the software where our floor starts and the floor to floor height. So we're starting with the ground floor at 0, and our slab to slab is 2.5 meters. The final dialog, wall thickness tolerance, the final edit box, is really to do with how far to look for a window when it's attaching them to a room. So that in most cases can be ignored unless you've got particularly thick walls. Okay, so let's register. We're going to register by layer here. We've got various choices. We can just select a window to register it. If you want to be specific about numbering, that may be the way to go. If we're not too bothered about what numbers we're using, we can just use the automatic registration, which is what I'm going to do here. So let's select number 32 window faces, and then we can just go register window by layer, and that's it. So we've got 5 windows registered. The first thing to note, we close these dialogues down, is that we've got our marker at the centre of the window, and if we look sideways on, you can see that they're facing outwards, and that's important. If our face was facing the wrong way, it was reversed, then our marker would face in, and basically our analysis would be wrong. So it's important to get that right. If it is wrong, there are options on the dialog. If we go back to that, you can see we've got this flip traffic light. So just click on the marker, click it again, and it will reverse it. So let's do the same for 34. The register dialog back up. This time we want to select the window faces for 34 and register window by layer. There we go. Okay, so let's carry on and do the rooms as well. So let's go back to room. And we can do exactly the same as we've just done with the windows by selecting the layers that we want to register. So I'm going to do number 32 first, bedrooms, kitchens and living rooms. So 5 rooms registered, and then we're going to do the same for 34. Okay, so let's take a look at the registration. So we're going to go to update this time rather than register, and we're just going to look at how these windows are being attached to the rooms just to make sure that that is correct. So I'm going to go query selected room, sorry, pick face to query, and you can see as I select the rooms it's highlighting the window that is attached to those rooms, and it looks as though everything's been attached correctly. So we can go ahead and start our analysis. Okay, so let's close this dialog. And just before we start running the analysis, let's just make sure our settings are correct. Okay, so to start with, we've got our project settings. And you can see straight away that the analysis type at the moment is set to proposed scheme. So we're actually performing a neighbour analysis here, so we just need to change that. And you can see the various criteria for VSC, annual probable sunlight hours and amenity, as well as the location that we're set at. So we just need to confirm that these are correct. Now these are already set to the BRE values, so we're happy with those. We're also happy with London. That's where our scheme is located, or the nearest location to that. So yeah, we just need to make sure that's set to London. And we've also got the tick box confirming that we're using the BRE location for our tests, not taking the location from the weather data. Okay, I think there's plenty of other settings as well, but at this point we're gonna skip over those. We'll come back and have a look at those in more detail later. Okay, so I've just saved the changes, and then we can close that dialog down. We can get all our layers turned back on again. And then we can select calculate daylight. And we basically need to create a list of the analysis that we want to run. So it's a task-based system. So we're going to start by adding VSC, and we're going to run everything. So you can run just a layer. Maybe if I wanted to run just number 32 windows, or I can just select individual windows to run calculations. But in this case, it's our first run. We want to run everything. So I'm going to add that to the list. You can see we've got 14 windows that we're going to be calculating VSC for. We'll do the same for annual probable sunlight hours. That includes winter probable sunlight hours as well. It does both calculations at the same time. We're also going to do daylight distribution, or no skyline. and also ADF. And once we've got our list complete, we can just click on the Run button and wait for it to calculate. The calculations are done in an external service, as you can see in the top left hand corner, and this will take a few seconds just to go through the different calculations. Okay, so all the tasks have finished successfully. Let's close this dialog down, and then we can look at the results in more detail. You can see that the traffic lights have now got some colour to them, and we've also got some text displaying the results at the various windows. So let's have a little look in a little bit more detail. Okay, so each traffic light marker is split into three areas. We have the circular shaped lozenge. This indicates the VSC value. So it's either going to be green, orange or red, depending on whether it's passing or failing. Orange indicates within 1% of a pass, but still failing. So here we've obviously have a failure for VSC. The A represents annual probable sunlight hours, and it's green, so passing. And the W represents the winter probable sunlight hours, and again green, so passing. You can see our window on the side here. We've got obviously a pass for annual, and we've got a fail, but only a marginal fail for winter, and then a pass for VSC. If you need to look at these results in a little bit more detail, you can do. And you can see we've got the room calculations there as well, the no skyline, the average daylight factor. We've also got our window calculations. So we've got the VSC values, existing and proposed, and then the ratio, 0.78. So you can see this is pretty close to passing, which is why this one's yellow. We've also got annual probable sunlight hours, existing, proposed, and the ratio, and the same again for winter. The text is all on separate layers, so these can be turned off individually as well. So let's turn off the APSH values and the VSC values. Okay, so let's have a look at the no skyline results. So let's select all the layers, freeze them, and then let's just thaw the existing no skyline calculations. Now if we just look at one of these rooms, let's take this one for example. Anything that's coloured, i.e. not black, effectively has visibility of the sky. So although we're showing two different colours here, yellow through blue, and there is some sort of intensity indicated by that, the actual value we're after is whether it can see the sky or not. So basically if it's coloured, it can see the sky, and that would go towards the percentage of the room that is receiving skylight. Let's have a look at the no skyline proposed. So you can see with the proposal in, you're reduced in this area here. And if we put the ratio on, this is showing you, again, blue is a unchanged area, red is showing you an area of loss, and if there's any green, which probably isn't on this example, but areas of green are gain. In other words, you've actually got more daylight available after the proposal has been built than you had before. So we've so far looked at the graphical side of no skyline, but we can also, if we just turn those off, we can turn on the no skyline values, or the data distribution values in the existing scenario. If we scroll down, we should have the same for proposed, and indeed the ratio as well. So that's no skyline. We've also got an output, a textual output for ADF as well. So let's just scroll down to that. Again, existing and proposed values. So as well as a graphical output that we've just been looking at, we also get an Excel output as well. So if I open the job folder, this will take you straight to the output, the various outputs that come out of the software. So let's have a look at some of those. So we'll start off with Waldron diagrams. You can see any output that is based on a Waldron diagram is going to give you diagrams as well. So that's VSC, annual probable sunlight hours, and ADF. So if we have a little look at VSC, and let's pick a window. There you go. So you can see it's actually a transparency, so we're seeing the existing and the proposed on top of each other, which gives you an idea of the impact. And we've got a value of 33.8 existing down to 25.52 proposed. And if I just scroll through right and left, we can go through each of the windows and the various outputs. And we can do the same for annual probable sunlight hours. So here we've got the 100 sun dots representing the sun's path throughout the year. The blue dots represent those in the winter months. The combination of the yellow and the blue would be the annual probable sunlight hours. And again, we've got the location, and we've got annual and winter suns, existing and proposed. If we just scroll through those, you can see the values changing there. And we've also got the Waldron diagrams for the VSC calculations for ADF. So you can see those with the existing and proposed sky component figures. Okay, so also we have a reports output. So we also have in the reports folder the tabular output from the calculations that we've run. So if we have a look at VSC, this is fairly self-explanatory really. So we've got the index, so number 32, first floor, window 1, has an ID as well, so window ID 17, the existing figure, VSC, proposed figure for VSC, and then the ratio between the two, and then whether it meets the BRE criteria. You've then got window orientation and the date and the version number of the software. If we look at ADF, obviously with ADF there's a few more values that go into the calculation. As you can see, they're all laid out, and again you've got the meets BRE criteria in this column here. Okay, so hopefully that gives you an idea of how to do a neighbour analysis. Thank you for watching.